So in this video, we're going to continue on with what we were talking about in the last video, discussing transformations related to quadratics. Right? So the do now problems are just talking about the same general idea. So for this, you can refer to the answer key online. What I want to do is get into the graphical applications of this. Right? So the directions graph all of the following equations on the given graph. So we have y equals x squared. Right? So you can use your calculator. You could also make a table of values, whatever way you're most comfortable with. The idea is that if you come up with a good parent graph, then every other graph is going to be that much more accurate. Alright, so this is my y equals x squared, or at least it's going to be in a sec. Ooh, a little shaky at the end there. So now I have to do y equals x minus 4 squared. All right, so again, and I'm just going to compare this to the standard form equation. Y equals a times x minus h squared plus k. Right. So it's the h value that dictates what the horizontal translation is going to be. Right. Horizontal shift, horizontal translation means the same thing. Right. So when I'm creating these two graphs, it really is just a matter of determining what those h values are going to be, because we have no vertical change here. Right? So for the first graph, which has an x minus 4, it's going to be a 4-unit shift to the right. Right? So every point gets shifted over 1, 2, 3, 4 units to the right. I wanted that to be in red. And so there is my y equals x minus 4 as a quantity squared. The other one is 4 units to the left. So every point on that original graph gets shifted 4 units to the left. Oop, that's too poor. Alright, so that's my x plus 4 squared. Alright. Doesn't look quite as terrible when I zoom out, but it's still pretty bad. Alright, so how are they similar? Same shape and orientation. How are they different? The vertex is at a different location for each one. So I'll say vertices, plural vertex. The vertex of each quadratic. I'm going to itemize it here a little bit. Y equals x squared. Vertex 0, 0. Y equals x, I believe the second one was x minus 4 squared. 4, 0. And y equals x plus 4 squared. negative 4, 0. So this is just another look at pretty much what we've been working on over the last few days. It's just in more of a graphical sense. Now consider the graph of y equals x minus 4 squared plus 2, where would you expect this graph to be in relation to the other two? What would its vertex be? What would its vertex be? It should be 2 units higher. Vertex should be at 4, 2. And there it is. So in this page, we just have a brief refresher of the vertex form of a quadratic. Vertex form and standard form mean the same thing. Y equals a times x minus h squared plus k, where a is the 1 unit slope. Oh, 1 unit's, that was interesting. 1 unit slope. H and k make up the vertex. Alright, so the questions that follow really just ask you to make a statement of what the vertices would be. Alright, so that shouldn't be bad, because in each one of these cases you're just making a statement. Once your equation is in standard form, and some of them already are, you're just making a statement of what the h and k values would be. So in the first one it should be 5, 3. The second one, there's that understood minus 0 here, so 0, negative 2.5. Negative 4, there's no k value here, so negative 4, 0. 5, 3.5. And negative 1, negative 8. So you can see in each case I'm reversing the sign of whatever is contained inside the parentheses with the x, and I'm maintaining the sign of the numerical value that's on the outside. Quadratic that has the given vertex. They didn't make a statement about the a value, so we'll assume a 1. So x minus 1.9 squared minus 4. X minus 0 squared, so x squared, plus 100. And y equals x plus 2 squared plus 3/8. All right. The next one, write a quadratic equation whose graph will have the given vertex using a leading coefficient other than 1. Right? So it's not really designed to be any more complicated than just giving it a leading coefficient other than 1. So anything you want. Right? So y equals 2. X minus 100 squared plus 200 can be whatever you want. Y equals 1/7. Again, can be whatever you want. X plus 3/4 squared minus 6. All right. And number 11, similarities and differences without graphing. One of them is more closely associated with the parent function, but they both have a vertical shift of 1 and no horizontal shift. All right. The second graph y equals negative 2x squared plus 1 has a stretch factor of 2 and is reflected over the x-axis. And again, we know it's reflected over the x-axis because we're looking at a negative leading coefficient. All right, so this part here has everything to do, or really bring it in there. Extreme close-up. Whoa! Whoa! Movie reference. That's the Easter egg for this video. So if anybody messages me with that Easter egg, then you will receive 1 bonus point. But again, it's first come, first serve. So whoever gets that to me first. On this page, we're reviewing how to complete the square to put the equation, quadratic equation, into standard form, or vertex form as we're calling it now. We've gone over this a few times, but no harm in going over it again. First step in the technique, subtract 12. Y minus 12 is going to be equal to x squared plus 4x. And I'm going to leave a space to complete the square. At this point, because we've been working on completing the square for over a month now, we're looking at moving closer and closer to this work being behind the scenes to the point where you shouldn't even have to show it. All right, so I'll write it again though. Taking the b value, cutting it in half, squaring it, and dividing it by the a value. All right, so my b value is 4, divided by 2 becomes 2, squared is 4, divided by my a value, so this is my a value, my b value. So 4 divided by 2 squared is 4, divided by the 1 is going to give me a 4. That number gets added to both sides. So on the left-hand side, we have y minus 8. On the right-hand side, we have a trinomial that is a perfect square trinomial. It may not be, after you complete the square, you may have to factor out a leading coefficient, but in this case, because the leading coefficient is 1, we don't have to worry about that. So I'm going to factor by taking the square root of my first term and my last term, only if they're perfect squares, carrying down the middle sign, and writing it as a binomial squared. Last step in the process is to bring the 8 over, the negative 8 over, make it a positive 8. Y is equal to x plus 2 squared plus 8, which gives us the a, h, and k values, but in this case, it's just saying write it in vertex form. All right, so this is as far as I would need to go. All right, it asked us specifically to do it by completing the square. So if you've come up with the vertex some other way, that's great. The directions here are specifically saying to do it using completing the square. All right. Next up, number 13. Here we have a leading coefficient that's negative, but that's not going to be a problem. Again, we're going to bring this 7 over to the other side. So y minus 7 is equal to negative x squared minus 12x. And again, we're going to complete the square. So I'm going to take my b value, highlight it for you. My b value, cut it in half, negative 6. Square it, positive 36. Divide it by the leading coefficient, result, negative 36. All right, so again, same technique. We're using that b over 2 squared divided by a. All right, so nothing new here. It's just now we have an a value that's not a positive 1. So we have to account for that. So I'm gonna factor that out. Negative 1 becomes a leading coefficient, x squared plus 12x plus 36, which factors to, again, square root of the first and last terms, x and 6, carry down the middle sign, write it as a binomial squared. On the left-hand side, it's just y minus 43. All right, cleaning it up, I'm adding 43 to both sides. Y is equal to negative x plus 6 squared plus 43. All right. The last couple of problems, you know, they're kind of along the same level of difficulty. Right? Nothing is ever going to be any more difficult, I would say, than number 13, one where you have to factor out something. It's just that thing you may have to factor out might be a fraction or something, but that shouldn't make it difficult because you have calculators. Now, back in my day, different story. So I'm going to knock off that 40, y minus 40, x squared minus 14x. Complete the square. Take the b value, cut it in half, negative 7. Square it, 49. Divide by the a value, still negative 49. So y plus 9 is going to be equal to x minus 7 quantity squared, which gives us y equals x minus 7 quantity squared minus the 9. Last up, number 15. Bring over the 12, so y minus 12. I got my negative 3x squared plus 18x. I'm going to complete the square. So take the 18, cut it in half, 9 squared, 81, divided by a negative 3 is going to be negative 27. So y minus 39 is going to be equal to this whole thing here, but we have a leading coefficient. Leading coefficients, that's not a highlighter. That leading coefficient is a negative 3, so I'm going to factor it out. X squared minus 6x plus 9. Factor that. We're looking at x minus 3 squared is equal to y minus 39. And then add the 39 to both sides. And that is not a 39. And there it is. Now I feel obligated to go back and box each of the remaining solutions. So the Easter egg for this video is going to be, what did I feel obligated to do? First person to submit that to me is going to get a bonus point, all right, through the Remind app.